update about last Friday. Okay, come, yes. Okay, I want to update all of you about last Friday. Okay, so last Friday, the recording that I did has no audio or had no audio. So there was a moment on our Google site that video with no audio was placed out there. Okay, but now, as of today, I've actually made a new video and replaced that already. Okay, so the new video, right, actually discuss every query of the same paper, but now in one video format. So it's not last Friday, sorry, two Fridays ago, yeah. That video was like no sound. So if you watch it, right, it's worse than PowerPoint slide. Last Friday, is it? Oh yes, then this so what I discussed on Tuesday, I also embedded into a new video. So you can watch one video for everything. Okay, so that's the update for you. Okay, so today, right, this is the very last Blender lecture. Okay, all right, so let's go, shall we? Question 1. How do I obtain all the answers in question 1? You say thank you, I'll help you out a bit. Okay. Okay, but actually the key phrase is how do you determine a predominant species? How do I know which one is C and what is the effect? Okay, so let's go for the answers right away. Okay, tripeptide. I realize nitrogen compound it could be a weak point for quite a number of you. Okay, so let's analyze this question. Right, so we have a table 1.1 that showcases the pKa values of the various functional groups present in each amino acid. Okay, now before we go into the placements of these pKa values, I hope you all can see that by breaking these two particular amide bonds, you can get the 3 amino acids out. Okay, so for me personally, right, okay, I will picture this in my head, break it up to form the 3 of them, and in my head, I also do this. This is how I see the placement of the pKa. Now, the problem is you are just going to be copying it. It defeats the purpose. Okay, so let's do a quick exercise. Can you try and break up the amino acids and place the pKa values first? I want to see whether your hunch matches mine. If you are okay with not breaking it out, that's even better because technically you should still be able to see the. Sorry, went off. You should still be able to see the functional groups before. After breaking. I say hydrolyzing, to be honest. Can you try out place the pK values to the correct place and see whether it matches? Then I will actually answer the second query just now. How do I even know the predominant species for this? There is a pretty good chance that this program today will keep jumping around, so pardon that. Okay, now there was a query about how do I know which one is B, amino acid B, which one is amino acid C, and which one is D, right? Okay, to know which one is which, right, actually is quite easy. Let me show you the trick to it, is that there are functional groups here that will not contribute to pKa. Will not. And they are the amides, this one, no pK value, and alcohol. Alcohol is neutral also. Okay, no pK value. So if you look closely, now let me change it to red. Okay, if I change it to red, is to circle up those that can contribute to pKa. So in this case, for the amino acid on the extreme right, it will be this and this, right? So there are 2 pKa values to the amino acid on the right. In the middle, you have this and this. Okay, why am I circling that part of the amide bond? Is because you need to hydrolyze it, let your NH turn into NH2, and C double bond O turn into COOH. Then you can start to see that they are basic and acidic groups already. Okay, so the one in the middle has 2 pK values, and the one on the right, on the left, this one has 3 of them. There's a carboxylic acid here. This is the alpha carboxylic acid. There's an amine. This is the alpha amine. And there's a COH. This is the R group COH. This is how we call them. Okay, the alpha carboxylic acid is just one carbon away from the alpha amine. So with the label, you should be able to spot which one is BCD because you see the label there. The school is actually trying to help. Okay, so there is one of them with 3, right? 3 values. The other 2 have 2 values, right? So obviously it's quite certain the leftmost one is amino acid C. Okay, so let me show you this one. So I dissected this into the same 3 amino acid sequence. So C is on the left, B is in the middle, and D is on the right. Then there was a question later on that says that one of the amino acid has 2 chiral centers. You can spot it already. Right, so you need to use that amino acid to answer that question later on. Okay, since we are on the chiral center thingy, how many chiral centers are there in amino acid C and D? How many chiral centers for C? Actually, there's only 1, right? Yep. So the fingers, right? There's only 1 for D also. Yep. So therefore, there's only 1 answer for that question about the 2 chiral centers. Okay, all right. Then with this, okay, let's double check. Do you have the same value as mine? Yes, right? Yeah, if you follow the label, it's quite intuitive. I just insert accordingly, right? So if you place it wrongly, it's because you may have misunderstood the labels in the header there. Yeah. Okay, I am not going to go through why this one is 8.8, why this one is 9.1, and why this one is 9.6. There are reasons, but for today, I don't think it's the time for it. Okay. Yeah. I will not go through. I will not go through. But there are reasons. Actually, maybe it could be a homework for you. It's A-level concept. Why these values are like this? Okay, but anyway, let's move on. May I ask how you obtain all the answers? This whole question is nitrogen compound, so please study again. This whole question is all amino acids, amine. So nitrogen compound is your weak point, I guess. Okay, but I will now, of course, I will not just brush it off. Okay, let me show you what are the key concepts that are tested here. So we have a term alpha amino acid. Okay, it's actually a definition. So I think it could be new to you. So you can take YIJC's answer. It's actually the phrase, right? The key words is that the amine and the carboxylic acid is to the same carbon atom. It's bonded to the same carbon atom. That's the key words they're looking out for. This carbon atom is called the alpha carbon. Okay, the alpha carbon, basically, when you see your ammonia and your carboxylic acid with a V sign like this, right? This V sign is not a V, it's actually CH2. There's a CH2 here. So this and this, sorry, this is the R group. Sorry, it's R group. Yeah, so this and this all bonded to the same carbon. That's the definition here. Okay, next. Now, I don't agree with YIJC's answer, so I want to present my version. Draw the display formula for B. Actually, you got to commit to the shapes for certain functional groups. So the carboxylic acid actually and the alcohol, I don't agree. You actually have to bend the alcohol. And for the carboxylic acid, this one must be trigonal planar. Let me zoom in. And this one must be bent. And this one must be bent. Yeah, this is what we taught you. So let's follow this instead. Let me remove the circles. So please edit. But all the bonds must show out. Now for the amine, this one, YI's answer and my answer here actually is okay. Supposed to be okay. Let's test each other. Do you know what's the shape to this nitrogen? Based on your BSCPR theory, this shape is this shape should be Wait, let me ask. What's the shape around this nitrogen? Trigonal? Pyramidal. Do you know why? There's a lone pair. I think you have forgotten. Nitrogen, when you see nitrogen in the compound, your idea is A, is that a lone pair? You're like the first auto thought. Nitrogen and oxygen, right? Your first automatic thought is there a lone pair there? Usually is there, yeah. Guarantee plus short one. Nitrogen with 3 lines, confirm there's a lone pair on. Right? Oxygen with 2 lines is 3 lone pair. So it's like the moment you see it's like, wow, confirm lone pair. Then for organic chem, lone pair means what? Nucleophiles. Straight away you got to start taking nucleophilic stuff already. Possible. Yeah. So that's your sensitivity about seeing certain elements in your compounds. Okay, right. So let's move on. Okay, this is the one I want to answer properly. Okay, how do you determine the predominant species and how do you know which one is C and what effect does the pH have? Okay, so I answered which one is C already. So I want to answer how do you determine the predominant species? So for A part 3, they are saying draw the predominant species at pH 4, right? So you need to look at the pKa values and see whether the environment surrounding it is alkaline or acidic to it. Basically, compare the pH. Okay, so for example, right, the environment now is pH 4, but this carboxylic acid is 1.88. So that means, with respect to the environment, this carboxylic acid will get deprotonated. It will contribute the H plus out to the surroundings, right? Because the surrounding is now lacking in H plus. So hence, you will deprotonate it and turn it into CO minus. Okay, so basically, if the pK value is lower than the pH of the surrounding, then it will deprotonate. So for me, when I teach this, I teach it in a pretty layman way. I'll say that the environment is more alkaline to the functional group. So I'll give off to my H plus. Okay, likewise for this carboxylic acid, 3.65 versus 4. 3.65 is acidic, is lower, so pH 4 is actually more alkaline. So I'll give away my H plus. But 9.6 is different, right? 9.6 to 4. 4 is more acidic to 9.6, so I'll get protonated. That's my way to see it. Yeah. So you can come up with a simple but reliable way that you can depend on for this. Choose yourself. Yeah. Yeah, right. So that is the meaning of predominance, which is you do your comparison of pH and pK for every functional group that's present. All right. And do you know that it's in your notes? This concept is in your notes. Okay. So revelation time is in your nitrogen compound lecture notes, page 18. Structure of amino acid at different pH. These 2 bullet points. I'll let you read it for yourself first. Right? Isn't that the same thing I just mentioned? Okay, so it's this part of your notes. Okay, if you want to find it, it's on page 18. Right, I don't have to read it out, right? Okay, that's the idea, is just compare pH and pK. Okay, right, let's move on. All right, is it okay, everyone? Okay, then what effect does pH have? Actually, is this one, actually, so kind of answer it. What effect does the pH have? Is that pH technically is an indicator for the concentration of H plus in the environment. Okay, so therefore you can use it to compare. Right, so I will say that this part answers both query at the same time. Okay, so I'll call it closer, this query. It's technically 3 queries in one. Okay. All right, then in part 4, there's no query, but I have an alternate answer to this. So JC's answer is choose any value between 1.88 to 3.65. Agree. I agree with the JC's answer. However, if you were to really go into pure chemistry, it's not correct. Okay, it's actually somewhere in the middle. So it's called the isoelectric point. The predominant species. But the problem is, YIJC is not wrong. Is that it's out of our syllabus already. It's taken out. So that's why the range is okay. So in order for me to just be a bit more purist here, okay, let me show you. It's actually in your notes again. Do you know isoelectric point is in your notes? Okay, so if you go to page 19 of your same nitrogen compound notes, right, there is an enrichment part about isoelectric point. I'll leave it to you whether you want to study this or not, but it's quite helpful when it needs to be. Okay, that. Yeah, because it's been a while. It has never come up for us some time, so we are not sure whether it will come up for your cohort. Hopefully not, hopefully not. Okay, but yeah, it's been a while already. Okay, so the idea is actually somewhere here, this part. Okay, for neutral amino acid, for acidic amino acid. That means the arginine is a acid functional group, and this one is the basic one. Okay, how do I color everything? Okay, but it's all over here, so you can read it. Okay, I strongly encourage you all to read it. Okay, next. Okay, then I'm also answering the question. Can I get to the answers for question 1 or right? So this one is about the amide. Why is there no pK value for this part? I think we all know it's an amide, right? So this one you have learned it before. Come on, you seen it in your PYS. So I don't think you will be struggling here. Okay, so let's move on. This is electrophilic addition, and it's the simple one, slightly on the simpler side. So everybody, your challenge here most likely is which one should be delta plus and minus here. So if you think of it, between the two halogens, bromine should be the less electronegative element. Okay, so delta plus here. I think that's your only challenge here, mainly. Okay, and the next thing is this part. You have just applied a rule in order to get to this carbocation ion. What's the rule? Markovnikov rule. Spell Markovnikov. M-A-R-K. That is where most people stop. Mr. Mark. Yeah, Mr. Mark is the one that comes with the rule. Lola, Markovnikov. What is Markovnikov rule? We added carbon with more H. What do you add to the carbon with more H? We add the delta plus part to the carbon with more H. Yeah, those of you who keep thinking we add H to the carbon with more H, you are stuck actually. You are limiting yourself. It's not the H, it's the delta plus of whatever. Okay, expand it. Okay, but actually the real concept behind Markovnikov rule is stability of carbocation ion, which this JC tested, okay, which is this one. Secondary carbocation ion versus primary carbocation ion. So this one, very important. If you are revising this, always remember to revise this. Okay, next.
carbocation ion，所以也是会 test。
Which one?
在马克尼克过后，他会问你为什么那个是 major product， 或者是 minor product。
Oh, yes, correct, yeah. Oh, yes, okay. Mrs. Wah just enlightened me about this one. Yeah, please go and revise why or how certain carbocations are more stable than the others. So you know that it's about the number of electron donating groups that can disperse a negative charge, right? But we also just covered something recently, the benzylic carbocation. Still remember that one? Where you can delocalize the positive charge into the pi electron cloud. Okay, so that one is another addition to this ranking. Okay. Right, then this one, nothing much. Actually, I feel that the questions are fair and reasonable. It's not easy. It's not, to be honest, it's not easy. If you cannot recall, means you really cannot recall. But if you can recall, then it's okay. So it's a pretty fair paper. Okay, but now I want to go into part 2. So this is 1C part 2. I need to go through this because we are kind of always stuck here. If you are like still stuck at the thought process, right? I hope today is the very last time you are stuck. You cannot get stuck here already. Because if you are stuck here, what have you done for this tutorial? This is a tutorial question. Okay, so a bit dangerous. So let's try and see how to get unstuck from here. Okay, so in our tutorial, based on the teacher's style, sometimes we draw circles, sometimes we draw square, sometimes we color code it. For me, I color code because I have the resource. Yeah. One node has the color coding. So do you notice that I color coded H's in two different ways? That's right, because there are actually different products formed from substituting these hydrogens. So if you substitute any of the red color H's, right, hydrogen atoms, you will get one chlorobutane. If you need to draw all 6 out for yourself, right, please by all means go and do it right now. Yeah, don't do it during A levels. It's too late. Do it now. Take it slow, but learn from that. Okay, any of the 6 H's in red. Okay, substitute any one, you get 1 chloro. Green color, there are 4 of them. Any one of them, you get 2 chlorobutane. So how many ways to get 1 chlorobutane? 6. There are 6 ways. How many ways to get 2 chlorobutane? 4. And we just take this as the ratio. It's the number of ways to get to the product. Okay? Now, I don't think I have done enough. If you are like still confused, okay, this is for everybody. Now I want to try a new compound, but I will only verbalize it. Okay, now let's do monochlorination on pentane. Straight chain pentane. Tell me the ratio. If I use pentane, what is the ratio? Don't worry, I'll give you a few seconds first, maybe half a minute, just discuss with your partners. Pentane. 5 carbons worth. Ratio is, you can point your fingers, is 3, 2, 1. Yeah, it's 3, 2, 1. There are 3 products formed. Anybody lost? Because actually, you're lost. Really? Let me just add here. Yeah, actually, I can just brutalize my diagram and then put a H and H. This pentane. Right, there are 3 possible. You can get 3 chloropentane, right? Yeah, okay. So there are 3 products. Therefore, the ratio is 3 to 1. I never change any color coding. It's the same because it's symmetrical, so it happens to be just like that also. So my point is, if I can just change the structure and test myself again, why don't you also try it on your own and change structure and test yourself? Just choose any alkane and test each other. It can help actually. Yeah, I only lengthen it by 1 carbon. Right, so if you are the one that asked this question, actually I'm almost done in terms of my explanation. I hope you're okay. Okay, and then for back to butane, okay, there's a phrasing that we call it is that these hydrogen atoms are considered as two types of chemically equivalent hydrogen atoms. When we say 2 types, means all the red color ones are chemically equivalent. All the green color ones are chemically equivalent. So when you substitute any one of them away, you get the same product. Okay. Right, I hope this helps. Otherwise, you will need for consultation, for sure. Yeah, this one is the one. Okay, and I'm pretty sure I'm done with question 1. Yeah, so I'm done. Okay, so to finalize this one, if you have question on the energy level diagram, this is only for covalent. This is the energy level diagram for covalent. Where's my product? Is it this one? Yeah, this one. This is a covalent molecule. So everybody, I just want to highlight this before I move on to question 2. Is that if you have to do an energy level diagram for a covalent molecule, never ever. Let me bring in the dramatic pause. Never ever bring in IE and EA. If you start doing IE and EA from here, you are dead. You just went off the rail. You will never get an answer. Covalent molecules don't even need to care about IE and EA. Okay, only ionic. So do you know that there are 3 types of energy level diagrams? One is for covalent, one is for ionic, and there's a special one that involve lattice energy, hydration, and solution. Yeah, and you can merge them anyhow also sometimes. So if you are not as good right now for energy level, the advice is to just keep on doing and get it wrong and learn from it, actually. Okay. Have you memorized all 10 definitions for enthalpy change? That's right. Some people nodding head. Some people shaking head. Okay, the people who are shaking head, currently on my observation, you're on the minority side. Okay, more and more people are nodding head. Okay, you may have to add it into a revision plan. Okay, I think we are done for question 1 more or less. Okay, and let's go on to question 2. Okay, so we have a question about this part. Okay, nickel alloys. That's my question. Yes, this is the first one. Wait, hold on. 2A part 2. Wait, 2A part 2 is state which two metals are present that are metals 3 and 4. Wait, what are metals 3 and 4? Oh, density, metal 3 and 4, pretty high. So I have to talk about density, right? Density high metals. Then we have magnesium, aluminium, iron, and cobalt. Yeah, they must be the transition elements. So your query about, could I answer this question using stronger metallic bond? No. I suspect is, I don't think you are asking the question here. I think it's for a different part, I suspect. Okay, I'm not sure. Okay, but if you're taking at face value, right, this is not the correct explanation. Right, density is on page 9 of our transition element notes. This part. Okay, yeah, it's over here. Yeah, we are looking at this one. So if you are here, I don't think I've addressed your question. Where should the question be actually? Metallic bonds. What's the metallic bond? Is it here? Is it part 1? Because part 1 is metallic bond. I think you're asking for part 1. Yeah, most likely. I remember. That's why I underlined or highlighted this. Is your question, can I just use metallic bond to replace all this? Is it correct? If that is your question, answer is no. You need to expand your description for metallic bond. So for YIJC, their metallic bond is between the lattice of positive ions and the sea of delocalized electrons, similar to ours also. So you need to expand your definition of metallic bond here. Okay, so that's my response here. All right, next we have, oh, this one. Okay, wow, this is a pretty fun question actually. Compound F. Okay, let's go for 2D. There was a query about compound F. Okay, for a reaction of compound F with hot acidified KML4 to form benzoic acid here, how should I know that the question is asking for side chain oxidation or strong oxidation alkenes? Thank you, but your thank you actually invited a response. Hi, if it helps, when there is a benzene ring, you can minus C6H5 from the formula C11H15Cl, and that gives C5H10Cl, which follows the general formula of an alkane, CnH2n plus 2. Beautiful. AKA sub 1 Cl atom and 1 benzene into alkane. Okay, to get F. This person can be a teacher actually. Well done, man. Okay, beautiful. Thank you. But for the rest of you, do you catch what the reply is saying? The reply is saying, check the formula before and after and see what changed, right? And I want to add on, I want to complement this answer, this reply, is that they say after oxidation, you get benzoic acid. So this is a clear sign that there's a benzene ring here. Yeah, okay, so therefore, it's in a way hinting that you got to consider side chain oxidation automatically from here. Okay, otherwise if you open up your options like alkenes oxidation, I don't know how you're going to solve it. It's too many variables. Okay, all right. Okay, so thank you for the reply. That's great. Okay, and may I ask how you determine G contains 1 less carbon atoms than F? Okay, and here's the thing. This is actually it's my only but main teaching point for our group today. Everybody, this is the big one. for the day. And I'm going to teach you like what we did last time. Okay, this is from idle form. Now, do you know that there are step-down reactions you have learned before? What is a step-down reaction? Carbon atoms goes down by one or more times, right? Okay, or more units. So in this case, right, it's one less carbon. Idle form is a classic one where you can always cut away one carbon from the original chain. Okay, so everybody, I'm going to teach you for 5 minutes about idle form. So this is compound F, right? And if you do not know when idle form arises, right, is that you need to convert this through nucleophilic substitution to get this compound. This compound here with the alcohol has no labels, but you need to know that this is the one that allows you to see the idle form usage. Everyone okay until this point? Okay, now the scary thing is you actually need to kind of know the mechanism for idle form. I repeat, you actually need to know the mechanism. Let's go through the mechanism right now together. When you add alkaline equals iodine, what happens? Before I show you the right hand side, make a guess. What happens first? Those who have read it, can you just discuss with your friend actually? Yeah. And those of you who never learned it among the few of you, make a guess, a calculated guess. What happens first? The very first thing that happens is this. It oxidizes the alcohol. Okay, so your secondary alcohol actually turns into a ketone. What is the oxidizing agent here? Some of you know, I can see. Some of you actually know. The oxidizing agent here is potassium manganate, my food. No, it's not potassium manganate. It's iodine. Yeah, iodine is the oxidizing agent. Hey, cannot oxidation always potassium manganate or dichromate? No. Okay. All right. Okay. Then this is the one I will have to go through with you because a lot of people forget all this. Do you know that after this, you actually repeatedly add 3 times iodine? Every time is plus iodine, plus iodine, plus iodine. Every time for 3 times before you get to this. Okay, here's the transformation in short. So in the middle, from CH3 to CI3, here's what you need to know. It actually changes to this. That is step by step until you get your CI3. After this, then you can start to break that part out. Where is the pale yellow PPT from in the first place? It's actually this part. So you need to get it out as CHI3, right? What is the reagent used in the next step to get CHI3? Let's try. Okay, this is the next one I want you to discuss. There's an arrow right below my diagram with the reagent. So what is that reagent you use to get CHI3 out? It will be your... Okay, what's the reagent condition for idle form? Just think about it. What's the reagent condition? Iodine equals ammonia. No, sorry. Equals sodium hydroxide and warm. Not heat, warm. I hope you remember that because strong heat will actually sublimes the PPT. Is OH minus. Sodium hydroxide is from sodium hydroxide. Then it breaks off like that. Look at this part. Everybody, look at this part. This was the original CI3, right? Now your CI3 is here. Then this part actually just replaced by O minus. So O minus here, H is here. You need to know this actually. It came out in A levels before, asking about the transformation. Can? Right. Do you know that it's in your notes also? Okay, let me show you. It's in your notes. So I source it out. It's under hydroxy compound, page 19. Please revise this part. The reaction takes place in 3 steps. It is not an enrichment. We did not place it under enrichment. You need to know this. Yeah, I see some of you reading it. Okay, now, not just that. There was a year which is a bit on the unfair side. They asked for the overall equation. So you need to know the balance also. So this one cannot AOHC. There's no way. You really need to memorize this. Okay, so please take some time to find out what is the coefficient for iodine, which is 4, hydroxide is 6. Then you get CHI3 plus 5I minus plus 5H2O with the compound form at the end like this. Yeah, so yeah, this one you have to brute force memorize it. Everyone okay about this? Okay, then finally, right, I want to say, right, what is the type of reaction isoform test is? How do we call it? It's called oxidation. But where is the oxidation? It's actually the alcohol turned to RCOO minus. Okay, yeah, just want to let you know. It's the carbon. It's the carbon that got oxidized. Okay, if you want to just double check the oxidation number of this carbon versus this carbon. Okay, and then you can match with your friends. Check the oxidation number change. Simple way is actually just one more additional O, right? That's secondary school way to see it. All right, okay, so I spent a bit of time on isoform, so please just be careful about this when you are revising. Okay, so therefore, that breaking of the CI3 part causes it to have one less carbon. Okay, so that's my response to this. All right, let's move on. What's this? May I know why do we need to times 1000 to convert kilojoules per mole? Yep, correct. Thank you. Well played. Next. Okay, 3A part 2 now. Why do we need to convert your delta G by times 1000? It's because you convert it to joules per mole. Why must you convert it to joules per mole? Why must you convert it to joules per mole? Actually, depends. Really depends. Whether you want to convert delta S to kilojoules per mole or you want to convert everything else to joules per mole. Up to you. You just choose one side, please. Yeah. Over here, this one different. This one, the delta G is always joules per mole. Therefore, you have to convert it. Okay, so I would say that you may have to remember this slightly differently from the usual delta G. Okay, when you're using NF N minus NF E naught. Okay. Right, next. Okay, 3B. Everybody, let's look at 3B. May I know how do you know that you have to use oxidation half equations for the metals? How do I know that I have to use EChem to answer this question? Okay, the answer is here. There is a phrase that hints at it. This is the phrase. Let's predict whether a reaction occurs. So when you need to predict whether a reaction occurs, it means you got to check whether that reaction is energetically feasible or spontaneous. If the reaction doesn't occur, you need to show evidence. What is the best way to show evidence? E-cell. Yeah. In your current syllabus is E-naught cell. That was the hint to ask you to do E-naught calculation actually. Yeah, right. So if this one comes out again, just check it out. And by the way, right, I hope you all still remember in your recent lecture test, you may have revised the tutorial, right? The tutorial also had this phrase, under galvanic cell. There was a phrase about predicting the reaction occurring. Yeah, it's the same phrase, therefore it's E-naught calculation, galvanic cell. Okay, right, next. Right, this is the one that I can go a bit faster because the queries are pretty easy to respond. So get ready. Right, there is a question about this. So for 3C part 1, okay, everybody, can we look at 3C part 1? Is to deduce the type of catalysis and explain how some transition elements can act as catalysts. So the answer is heterogeneous. And It's about partially filled 3D orbitals. The query was, instead of talking about that, can I use variable oxidation states? And my response is no. That is for homogeneous catalysis. Right now, when I was lecturing transition elements to the whole group of all of you, right? I mentioned this in my lecture. There's actually two boxes between page 14 and 15. One box is about homogeneous catalyst, and the other box is for heterogeneous. Okay, let's go one by one. Homogeneous catalyst, the characteristic is different from the heterogeneous one. This is on page 14. Right? Okay, so if you are using different oxidation state, it must be for homogeneous catalysis. Right? It's written here. But the question here is about hetero. So therefore, you can see why I also choose this answer. Okay, so I hope this one answered quite clearly. You got to know them differently. Okay, you got to know these two modes of catalyst, the feature differently from each other. Is that okay? Those of you are reading this, is that all right? Okay. Right, so it's on page 14 and 15 of the transition elements lecture notes. Okay, I also realized something. Is that a lot of your queries for this paper is all on the later chapters, this year's J2 topics. Okay, so here's the thing. Okay, everyone, I'm not sure whether you fall into this trap, but I tend to hear people revising from chapter 1 onwards. If you keep on doing this method, right, chapter 1 is always your most familiar ground, and chapter 23 is the worst. Okay, from now on, right, you got to hit your weak points. Go straight to it. You cannot go sequentially in order. No order. Not efficient also. Yeah. Right, go straight to your weak points. Okay, revise from there. Right, so if you find that your transition elements or your nitrogen compound is very weak, right, start from there, then work backwards. Then some things can start to make sense if you see backwards also. Okay, right, move on. Okay, then I think this one is okay, right? This is actually, what's this? Phenoxide reacting. Wow, this is an interesting one actually. I quite like their mechanism here. It's nucleoadd but on a phenoxide ion. Using a phenoxide ion. Yeah, this is a pretty unique one. So do try this one out on your own if you are like stuck. This is actually my favorite question here in the paper. Yeah. Okay, next one is here. All right, okay. This one I may have to ask Mrs. for advice also. Okay, Mrs. Paul, you help me out. Hi, teachers. Can I write something like let A be this one and refer to the compound as A for the rest of the question so that I don't have to keep on writing the full name? Lazy lah. But is it okay? Answer for me is okay. Huh? Yeah, only within that part. Yeah. Yes. Every part. Yeah, must. If you need to change a new question or new area, you got to redefine it. Correct. We don't know how can reach. And by the way, right, class, your label may clash with another question's label. So there's a problem sometimes. Within the same question, another part may have the same label. You got to be very careful here. I know this one can cause a lot of issues. Oops. Okay. So maybe you want to try out on your TYS and see whether it works. If it works for you, then you can apply for A-level. Yeah. You can let your teachers see your answer and see whether it works. If it's okay, then as long as there's no ambiguity, I think it's all okay. Yeah. And by the way, actually, my advice is I don't even want to go for names. Actually, I would rather you all right copy the diagram into answer. That means literally draw the structure just to prevent like misspelling and then get the structure differently. I just literally draw this one into my answer. Yeah, that's another way to circumvent this issue. Okay, right. Next one. Okay, this is question 4. Yeah. Okay, question 4. Oh, hi teachers. Sounds like the same person. For calculation questions for 4A part 2. What's 4A part 2? Oh, this one. Oh, yes. Okay, there's an alternate answer. Okay, let me show you the query. For calculation question, if my final answer is slightly off because I use different SF in my intermediate workings, but all my steps and everything else are correct, will I get penalized? No, you'll get it. And because you got 8.34, so I took some time to figure out how to get 8.34. It seems that you have taken everything for SF, right? Whoever asked this. If you get everything for SF, you get 8.335. But I tried every other SF, right? You will not even hit near this number. This is the highest possible number that I can get from all the numbers above. Yeah, everything else, right? 5 SF, 3 SF, 6 SF is 8.33 something that is lower than 5. Yeah. Okay, so I will say that your answer will still be marked correct. Will be marked correct. Okay, guarantee plus short mark correct. In fact, right? Their answer here is a bit weird. They go for 5 SF apparently, but this one should be 6 because it's 5 recurring decimal. And this one should be 7, 8 because it's 7, 7, 7, 7 all the way recurring. Okay, yeah. So if you are here, this okay. No, nothing wrong. Okay, next one. Oh, this one. Let's go for 4B part 2. Okay, I may have gone a bit faster. So okay, everyone is about the sketching. How SO2 will behave. So it's a bit of a weird question here. Yeah. Sketching real gases on this graph actually is not in your syllabus, but however, the JC tested this. Okay, so at a higher Kelvin, right? 700. Okay, the graph is closer to the ideal gas line. Okay, the trick is actually to see the distance away from your upper parts and lower parts like this. Okay, yeah, it should be closer to the ideal gas line. Okay, so the idea here is that because it has more kinetic energy, so the intermolecular forces become less significant. The query was, can I say that the particles have sufficient energy to overcome the intermolecular forces? Answer is, actually, this is the reason why it becomes less significant. So you are actually bringing in the reasoning to supplement the outcome. This is the outcome actually to answer the question. So if your answer is to replace it, not really correct, but if your answer is to add on to it, yes, it's about add on. Okay, so you cannot really form the intermolecular force. So it operates almost like an isolated gaseous system. Okay, yeah, add on, yes. But if you use this to replace, maybe your answer is just short of the actual outcome, not enough yet. Yeah. Right. Okay, in our notes, right, ideal gases have no intermolecular forces, right? Oh, you still remember that one? Okay, so your outcome is in real gases at high temperature is negligible. The intermolecular forces will become negligible. So that's the same thing. Okay, and then I think that's all I have for question 4. Yeah, question 4 is actually quite short because that's it. And then question 5, I only have one query. Only one, right? It's all the way at 5E. But before we go on to that, and I have only 3 minutes left, this kinetics graph okay, ma? For everybody? Is it okay? Okay, right? Right. This paper is decent, so I hope y'all got your A. You managed to get 60 marks or 50 something marks. I hope so. All right, it's about this one. Okay, hi teachers, how do you form M and L? Okay, so for this question, right, 5E, the elucidation, right, M is hinted here, tertiary alcohol. All right, so the logic now is I need to form M with a tertiary alcohol in the middle, right? Okay, so if you look at the formula, right, the formula for M, right, is only C4. C4H, I think 6, right? 1, 2, 3, 4, 5. Yeah, there's not enough hydrogens to play with. So hence, right, this is the only answer together with the tertiary alcohol hint. Right, so I would say that M, right, is quite easily gotten, to be honest. Right, so this is how you should get M. Now I will go into how to get L. L is not that tricky actually. So here's how I do it. Okay, look at this. right? So L splits into three things, right? My M is settled. My N is also settled, is the ethane dioic acid. Then my CO2 is also settled. Yeah, two terminal alkenes. So now the idea is, how do I place them, right? This school quite smart. The way to form L has only one way. Okay, yeah, there's only one way. There's no alternate answer. Very smart. Okay, you have to just merge it like that. So you put your CO2 at the end so that you can get back your terminal alkene. M and N can interswitch, but it's just inverted only. Doesn't matter. You can put your N before M also can. Okay, it's still the same compound. So very smart question here. Okay, so for me, right, this is how I do it. So I'll put all my CO double bond pointing to each other. Then I'll solve it right now. Okay, now is to form back the alkene. So once I form the alkene, this lecture is officially over. Done. Okay, let's form L together. So I need a terminal alkene at the end, right? Terminal alkene. Here now, C, then remove the H. Sorry, wait, remove the O. Sorry, remove the oxygen. Okay, then the tertiary alcohol stay put. Don't touch it. Next one is here. C with a H, remove the O. Alkene, CH. This part, right? CH, then CH again. Then CH2, terminal alkene. And that's your compound L. Yeah. If you swap M and N, right, it's the same answer. Done. End of lecture. Really. Okay, yeah. So this compound L, right? So the idea for me is just to point the C double bond over and then remove all the oxygen as you convert it back. Okay, and with this, we really have arrived at the very end of the banner lectures. So yeah, 10:20, that's nice. Okay, all the best to you all, everyone, for your prelims. Okay, if you need help, just let our tutors know. Okay, good luck for this weekend. Practical, right? Revise practical like mad, right? Okay, all the best. All the best. Yeah, dismiss.